Let's illustrate the difference between a traditional non-Java generics, a way of implementing a collection. So what you're looking at is a free online website. This is an online IDE. Execute this. This hello world works. So let's just start off from here. Keep calling it this is hello world. I like to enlist the use of an array list. This is typical Java collection APIs. Import this as well. You can do a util star if you like, but I like to just import what is needed and nothing extra. We're going to make use of this to illustrate the collections implementation. Let's create a stack. In Java, you can use array to create a stack if you like. So array list is a dynamically sizable array. So once you have this, you can keep adding items to it, right? Right now, this list is empty and there is no specific generic types associated with it. This means that you can push any Java object into it of class object. Everything is an object in Java. So you can push in, let's say Java, right? The entire string itself, this instance is a Java object. You can also add, for example, a new integer, let's say 8 to it. This is good. And this is also good. Let's compile this. This works. So if I were to, let's say, iterate through this, you can do that with object, let's say, through the list, right? So this is going to give you the two objects that you just inserted. But the problem here is you don't know if this object coming out of this list is integer instance or a string instance. If you do something like this, for example, a string s equals, try to cast, because you don't know what this is, and you try to do that, this will work for the very first one, but it will not work, obviously, right, for the second one. So let's just see what happens if we execute this. And you can see here there's a class cast exceptions. So this won't work. Can we use Java Generic to fix this? It turns out we can. So Java Generic came out in 2004, Java 5. So in order to turn this into a generic version, so you can say, remember generic starts with this angle brackets, right? And you said, I want this to be a string only. So what you can do, you can say, I want a type safe string. So this list moving forward at compile time knows that at runtime, it can only take string instances. This won't work. In order to make this work, you can simply just say, hey, this is not an object, this is a string. Then you don't have to type save, you don't have to cast this anymore. If you like, just print them out and see what happens. So let's compile this. This works. We just assign a generic type, compile time, and it's type safe. Moving forward, you can push all of the string instances into it. But let's say if we don't, instead, we decide to do something like this. Is this going to be okay or not? When you execute this, no, it's not, right? And this is pretty obvious because you're telling this entire collection to accept a string at runtime, meaning all of the elements inside of this buffer has to be a string. And now you're putting integer into it. So you have to comment this out in order to compile this. These are the two quick illustration of the non-generic collection versus the generic collection. So ultimately, you can call the collection stack. Okay, stack is just an ADT. We're talking about data structure here. Okay, so hopefully this illustrates the generic versus non-generics.